In this video, I am going to discuss about casting defects. Defects in a casting are basically classified into three types: surface defects, internal defect, and visible defect. Surface defect are commonly occurs in the surface of a casting. Internal defect means which will be occur at the internal or inside the casting, and visible defect means which can be seen by our eye. There are 7 types of surface defects. First one, blow. Second, scar. Third, scrap. Fourth, drop or crush. Fifth, penetration. Sixth, flash or fin. Seventh, blister. There are 3 types of internal defect: blowhole, pinhole, and last one, inclusion. And there are 9 types of visible defect. First one, wash or cut. Second, hot ear. Third, shrinkage. Fourth, rat tail or buckle. Fifth, swell. Sixth, shift or mismatch. Seventh, misrun. Eighth, run out. Ninth, fusion. So these are the wide classification of casting defects. So we can discuss one by one. So first of all, I am going to discuss about surface defects. So first one is blow. See, blow is relatively large cavity produced by gases which displace molten metal from mold. Blow occur convex casting surface. So blow means the defect blow is usually occur in the convex casting surface. Convex casting surface. At the top of the convex casting surface, relatively large cavities are produced by the gases which displace the molten material, and that defect is known as blow. You can see that this is a convex casting surface. At the top of the convex casting surface, there will be a large cavity which is due to the gases that replace the molten material, and that defect is known as blow. Second one is scar. Scar is a shallow blow that generally occur in flat surface. If this hole is present in a flat surface with a small size when comparing to blow, that defect is known as scar. So scar is a shallow blow that generally occur in flat surface. Third one is scrap. See, scrap are rough irregular projection on surface of casting containing embedded sand. That is known as scrap defect. So you can see that this is a scrap defect. Scrap are a rough irregular projection on surface of casting containing embedded sand. See, these are sand. Scrap occur when portion on the mold face or core lift and metal flows underneath in thin layer. So this is the reason why a scrap defect will be formed. Okay. Fourth one is drop. See, this defect occur due to a portion of the mold break and dropping into the metal. See, drop means a portion of mold. Suppose this is a mold cavity. This is a mold cavity. A portion of the mold break. See, this portion will be break, and this portion, the sand will be fall into the molten metal, and the molten metal that will fill this area, and that is known as drop. So this defect occur due to portion of the mold breaking and drop into molten metal. Next one is metal penetration. See, when the fluidity of liquid metal is high, it may penetrate into sand mold or sand core that will produce a rough casting surface with irregular projection is known as penetration. So what will be penetration means, if the fluidity of the liquid metal is very high and the velocity of liquid metal will be also very high, the liquid metal that penetrate the gap between the sand grains, then what will be happen? An irregular portion will be produced over the casting surface, that is known as metal penetration. Next one, flash or fin. See, flash or fin usually occur in the parting line surface due to SS metal used for casting. See, due to SS metal that is used for casting, a projection will be formed at the parting line surface, that is known as flash or fin. Next one is blister. Blister is a shallow blow like a scar with a thin layer of metal covering it. See, blister means that is a shallow blow like a scar, but a thin layer of metal that covering is. See, there will be a blow will be there, a thin layer of metal covering the cavity, that is known as blister. You can see that. You can see this. Shallow blow like a scar with a thin layer of metal covering it is known as blister. So these are the surface defects. So we have 7 classification of surface defects: blow, scar, scrap, drop or crush, penetration, flash or fin, and blister. So next one is internal defects. There are 3 classification of internal defects. First one, blowhole, second one, pinhole, and third one, inclusions. So first one, blowhole. Blowholes, it is also known as gas holes or gas cavities. See, blowholes, other name of blowholes are gas holes or gas cavities, are well-rounded cavity having a clean and smooth surface. This is due to gases carried by the hot metal. The blowholes are bubbles of gas entrapped inside the casting. So what is the reason for blowholes? See, blowhole is an internal defect. Blowholes are usually occur at the inside the casting. It is also known as gas hole or gas cavities. The main reason for blowhole is gases trapped inside the molten metal, and that space will be not occupied by the molten metal. And this defect is seen as a round cavities having clean and smooth surface. The main reason for blowhole is gases that is entrapped inside the molten metal. See, this blowhole can be controlled by controlling moisture content, providing proper ventilation, not too hard ramming of the mold, and controlling binders. So in this way we can control the blowhole defects. So controlling moisture content, providing proper ventilation, not too hard ramming of the mold, and controlling the binders. And second internal defect is pinhole porosity or gas porosity. See, the pinhole porosity or gas porosity, the main reason for this defect is gases absorbed by the molten metal. Okay. Practically all metals absorb oxygen, nitrogen, and hydrogen. Oxygen and nitrogen form corresponding oxides and nitrites, and hydrogen is responsible for causing pinhole porosity. So it is also known as hydrogen porosity. So the reason for pinhole porosity or gas porosity is hydrogen absorbed by the molten metal. See, the molten metal picks up hydrogen from fuel, moisture in air, and mold. As the metal solidifies, the solubility of hydrogen decreases considerably. The hydrogen thus comes out forming a number of small holes distributed throughout the metal. So this is the reason for hydrogen porosity, gas hole porosity, or pinhole porosity. See, the molten metal that absorb hydrogen from surrounding atmosphere, and the solubility of the hydrogen will be decreased during the solidification time. The hydrogen thus comes out forming a number of small holes distributed throughout the metal. See, pinhole porosity is quite common in aluminum alloys. In aluminum alloys casting, pinhole porosity is quite common. Okay. See, you can see there will be large number of very small sized holes present over the casting surface, that is known as pinhole porosity. Okay. Then third internal defect is the inclusion. See, inclusion, any foreign material present in the casting is known as inclusion. Any foreign material, that may be slag, dirt, or anything that will be present inside the casting is known as inclusion. So inclusions are defined as any foreign material present inside the cast material. Okay. So these are the internal defects present in a casting. That is first one blowhole, second one pinhole or gas hole, third one inclusions. Next one is visible defects. Visible defects are defined as defects that can be seen by our naked eye. There are 9 classifications of visible defects. First one, wash or cut. Second one, hot tear. Third one, shrinkage. Fourth one, rattle or buckle. Fifth one, swell. Sixth one, shift or mismatch. Seventh one, misrun. Eighth one, run out. And ninth one, fusion. So we can discuss one by one. So first one, wash or cut. So this is the wash or cut. You can see here, this is wash or cut. See, wash or cuts are projection on the drag face of a casting. See, this is the drag face of the casting. Projection on the drag face of the casting that extend along the surface, decrease in height as it extend from one side of the casting to other edge. That is known as wash or cut. So wash or cut is defined as a projection on the drag face of the casting that extend along the surface, decreases in height as it extends from one side of the casting to other edge. So you can see that this is a wash or cut that will be seen in the drag face of the casting. Second one is hot tear. This is a very important defect. Actually, hot tear is a solidification defect. See, hot tear is irregular internal or external crack occurring immediately after the metal have solidified. See, this hot tear is usually visible in the abrupt change in section. Abrupt change in section means sudden change in section. We have any sharp corner, the crack will be producing during the immediately after cooling, that is known as hot tear. So hot tears are defined as irregular internal or external cracks occurring immediately after the metal has been solidified. Next one is shrinkage hole or shrinkage cavity. See, we have already discussed that what you mean by shrinkage. So shrinkage is defined as the volumetric contraction that will be happen to the casting during the solidification. So during the solidification, the entire volume of the casting will be get decreased, and that process is known as, that is a defect in casting, that is known as shrinkage. In order to avoid the shrinkage, the riser will be used. Okay. See here, the shrinkage means depression in surface or internal void caused by solidification shrinkage that restrict amount of molten metal available in last region to freeze. See, actually here the shrinkage means some cavities will be forming. Due to shrinkage, the molten metal is not available to fill this cavity, and that is known as shrinkage cavity. Due to shrinkage, the entire casting will be shrink, and there will be cavities will be formed last freezing region, and the molten material that is not available for filling this cavity, and that defect is known as shrinkage cavity. Okay. Next one is swell. See, swell is an enlargement or bulging of the vertical face of a casting surface due to high liquid metal pressure. See, swell is an enlargement or bulging of the vertical face of a casting surface due to high liquid metal pressure. It occurs due to improper ramming of the mold or not properly reinforcing deep mold. So you can see that this is a casting. Due to high metal pressure, molten metal pressure, what will be happen? There will be a depression will be creating here in the vertical wall of the mold cavity. Into that depression, the molten material will be filling, and after casting, there will be a bulging will be occurred in the vertical face of the casting, and that is known as swell. Okay. Next one is shift or mismatch. See, the main reason for shift or mismatch is the cope and rack parts of the mold not remaining in their proper position. So you can see that this is the defect mismatch. It is also known as shift. See, the cope and rack portion of the sand mold are not remaining in proper position. There is a small shift will be there. Due to this shift, there will be a defect will be occurring casting. That defect is known as shift or mismatch. This is caused by loose box pin, inaccurate pattern developing, or carelessness in placing the cope and rack. So this is the reason for shift or mismatch defect. So shift or mismatch, a mismatch is caused by the cope and rack part of the mold not remaining in their proper position. This is caused by loose box pin, inaccurate pattern developing, or carelessness in placing the cope and rack. Okay. So next one is misrun. See, misrun means some portion of cavity are not filled with molten material. You can see this portion is a vacant portion. There is no molten material is filling. See, what's the reason is casting that has solidified before completely filling the molten material. Molten mold cavity. Casting that has solidified before completely filling the mold cavity is known as misrun. If the temperature of the molten material is very less, there is a chance that before the entire mold cavity has been filling, the casting has been get solidified. And that defect is known as misrun. So misrun is a defect due to a casting that has been solidified before completely filling mold cavity. Okay. Next one is cold shunt. See, cold shunt is a defect usually occurring. There will be more than one gate is used for supplying molten material into the mold cavity. See, here you can see that this is the casting, and which consists one gate here and another gate here. So through both of the gate, molten material will be flowing into the mold cavity. Then what do you mean by cold shunt? See, if the mold cavity is supplied molten material from multiple numbers of gate, due to less temperature, this molten material physically contact, but there is no metallurgical bond is created. That defect is known as cold shunt. The main reason for cold shunt is low temperature. So the molten material that will physically contact, but there is no metallurgical bonding between the molten material or portion, and that is known as portion of casting, that is known as cold shunt. Okay. Two portion of metal flows together, but there is no lack of fusion due to premature freezing. That defect is known as cold shunt. Then runout. See, runout occurs when the molten metal leaks out of the mold during pouring. This is caused by defective mold box, faulty clamping and weighting, and by casting too near the edge of the box. See, what's the main reason for runout is the molten material leak out of the mold during pouring. Molten material leak out of the mold during pouring, and it will produce a defective casting that is known as runout. Then we have fusion. See, when the mold sand does not have high refractory strength, or the metal is poured at very high temperature, or the facing sand is poor quality, the sand may melt and fuse with the casting surface. This gives glossy appearance to casting. So what I mean by fusion is, if the sand that will be contact with the molten material have less refractory strength, the sand which is contact with the molten material is known as facing sand. So if the facing sand have less refractory strength and the molten material have high temperature, so the sand may fuse with the casting surface. This will give a glossy appearance to casting, and that defect is known as fusion. Okay, next one is buckle. See, buckle is long, fairly shallow, broad V depression that occurs in the flat surface of a casting. See, buckle is defined as the V depression that occur in the flat surface of a casting. V depression only known as buckle. So you can see that there will be V depression here and also V depression here. So the V depression that occur in the flat surface of a casting is known as buckle. The last one is rattle. See, rattle is long, shallow, angular depression that in the surface of flat casting, it is not shaped like a V. See, depression other than V that will occur in the flat surface of a casting is known as rattle. See, this is a depression that is other than V shape, and that defect is known as rattle. So these are the classification of defects in casting process. There will be lot of defects will be there. So you have to make a understand about all the types of defects. So casting defects are basically classified into surface defect, internal defect and visible defect. Okay, thank you.